Hello students, in this video I will explain the derivation of the phase rule. Phase rule is F is equal to C minus P plus 2. So it relates the degrees of freedom with the component and the number of phases. So degrees of freedom is the number of variables that we need to know in order to define a system. So for this, let us consider a heterogeneous system. Heterogeneous system means a system consisting of different phases that are not miscible. Heterogeneous system consisting of p number of phases like p1, p2, p3 till p, and c number of components like c1, c2, c3 till c, like that. And also the system is in equilibrium. And the components are existing in all the phases, but they are not reacting with one another. So we should assume that the passage of component from one phase to another takes place, but there is no chemical reaction between them. Number of independent variable depends upon the composition variable, temperature and then the pressure. Composition, temperature, pressure are the variables to define a system. So for pressure and temperature we are putting the number 2. So it is fixed, pressure and temperature is fixed. So for composition variable alone we need to work out. So for example, if the system consists of 4 components, C1, C2, C3 and C4, if we know the composition of C1, C2 and C3, we need not know about the C4 composition, because we can get it from 100 minus some of the compositions of C1, C2 and C3, isn't it? So we need not know about composition of one of the component in the system. So for that we can write like, since composition of one of the component, one of the component we need not know, then we can write it as C minus 1. C minus 1. C is the number of component. So for one component we need not know the composition. So we can write it as C minus 1. For p number of phases, we can take it as p into C minus 1. So now the number of independent variable will be equal to, so in the place of composition variable we can write it as p into C minus 1. Okay, so p into C minus 1. So and then plus 2. So number of independent variable will be equal to p into C minus 1 plus 2. Okay. So now let us take next term, that is chemical potential. So chemical potential means potential with which the components are existing in the phases or getting mixed in the phases. So at equilibrium, the chemical potential of all the components or chemical potential of one component is same in all the phases. Chemical potential of one component is same in all the phases. So this is during when the system is in equilibrium. When the system is at equilibrium, the chemical potential of a component will be same at all the phases. So this is represented as mu. Chemical potential is represented as mu. Mu 1 means chemical potential of component 1 in phase 1, and chemical potential of component 1 in phase 2, chemical potential of component 1 in phase 3, everything is same. Okay, so chemical potential in phase P, like that. So like that we can write it for chemical potential of component 2 also. Okay, so this then we can write it for until chemical potential for component C. Okay, that is chemical potential of one of the component will be same in all the phases. So that's the meaning. Okay, so since the chemical potential of the component is same in all the phases, if you know the chemical potential of a component in one phase, we need not know about the chemical potential of that component in rest of the phases, because everything is same. So that is that fixed variable, that is for rest of them we need not know, right? That we call it as a fixed variable. That fixed variable can be written as p minus 1 into c. Okay, so p minus 1 in bracket into c. So that is the expression for that fixed variable which we need not know. So that p minus 1 into c has to be subtracted from the independent number of independent variable. Okay, so this fixed variable, that is p minus 1 into c, p minus 1 into c has to be subtracted from the number of independent variables. So finally the total number of independent variable will be equal to c minus 1 in bracket into p, or p into c minus 1, p into c minus 1 plus 2 minus p minus 1 in bracket into c, p minus 1 in bracket into c. So when we solve this, you get c minus p plus 2. So total number of independent variable is the degrees of freedom f. F is equal to c minus p plus 2. Okay, so this is the Gibbs phase rule. Thank you.